Hello, in this video, we're going to get into the topic of limiting the location of points by tools and by grid, which is important because all of the geometric figures that you'll make on GeoGebra are their location is based on points. So if you don't, you sort of have control where the points are, then you're going to, you're not going to have control of the visual that you're hoping to give. So this first diagram is, I mean, it's a really simple demonstration where you have the length of this being 12, the height of this being 5, and you see, half of that product is 30. So it sort of gives an impression of how we find area of a triangle. But I wanted you to notice that if this is a demonstration that you make and you're in control of the points, you may want to make it so the points are completely free. I mean, there's no reason not to, really. I mean, so this is again, it's just there would be a difference, I think, if you had the kids, having the diagram, because if the kids had this diagram, they might be able to sort of go off like that and sort of, just to mess with the whole assignment, or it might zoom in or zoom out, or there's many different sort of things that could happen. They could, so you want to be in control. But if this is just you doing something for the class, there's no reason to necessarily, you don't need that. So, but this is just an example of that. The other thing, though, besides whether you decide to make the points free to go where they are or not, is this right here, which basically gives the points freedom to either go only on the grid lines or go wherever they want. So if I put it on automatic, which I'm going to do, this changes things in terms of it can go really wherever it wants, right? So if I go like this, let's say I go like this, and you notice that says 26. But if I go to rounding and I go all the way to, let's say, 10 places, we'll find out it's not exactly 26. And that might present a problem here and there with regard to when you have the base listed as one number and you have the height listed as another, the numbers may be rounded and therefore they won't necessarily add up to what you think the area should be. So it's something to consider, with automatic. I mean, you may have to explain to the kids why, with rounding, why the numbers don't necessarily make sense when you're rounding to, say, like the first place or whatever you're rounding to. So, if you have things on fixed to grid, you're going to have whole numbers, or you're going to have numbers that are at least, well, it depends on how far apart things are, but the numbers will make sense a lot with fixed to grid as opposed to automatic. So it's something to consider. Here's an example of another way that automatic versus fixed to grid may cause problems. I'm going to put the angles in. All you have to do is just click here, like click on the center of it, and click here, and I get the 3 angles. And I'm going to show you how, if we have fixed to grid, and I have this point on the grid lines and this point on the grid lines, watch how easily it is to make a right angle. Just go like that, and now that is 90 degrees. Now, I made this point here fixed inside the grid line. So what that means is that it's going to be very difficult. I'm going to put it on automatic, but if I want to make this into a right angle, let me see, is it on automatic? Yeah, it's on automatic. So if I want to make it a right angle, it's going to be very difficult to do that. I think it's going to be actually impossible to do that. I mean, when you think about these numbers inside here, go to like the 10th. I mean, they're infinitely precise. So if you were gonna give younger kids something, you want them to be able to make a right angle, you'd probably do fixed to grid. I do for my high school students, though. I do this where I say, okay, this is right here and this is right here. How are you going to make that at a right angle? And of course, for that, they would have to make a perpendicular line from here and drop it off there, and then they have to make it so. Let's see, I put a point on here, and I can tell it's on the line again. because it's a different size and it changes color. So yeah, so that's on there. So then I would just say, okay, I want this to be right there. So I'm going to double click on this, and then I'll open up the location, and I can just say point G, and then okay, and now I have my right angle, right? So that's something, in terms of having students, use construction to create things, they got to be thinking about perpendicular lines, and then, well, that point just has to be on the line somewhere. I like that part of GeoGebra, it allows you to create stuff. So that was the automatic versus fixed grid issue. We talked about in the first diagram where the triangle could be moved wherever you wanted to. Sometimes with kids, you don't want to give them that freedom if you're giving them a diagram. So it might be a smart idea to create an underlying structure. So this is what I did for this. I just, if you can notice, there's a excuse me, there's a segment from here to here, and I attached a point on this segment from here to here, and I attach this C point on this segment, and then again here to here. So I put some limits on, how big or small this can get. That's how wide it can get over there, and then this one can go like this, back and forth, right? And this one as well can go like that. Okay, so that's just an idea in terms of, I mean, sometimes you may make a circle and have it go all the way around a circle. There's different things you can do, but in terms of preserving this activity, for kids, in having not having something go wrong with the diagram, it's a pretty good idea to do that. After you make this, you would go and you would hide all these things. You go where it says show object and object properties, which is of course right here, and you would go click on that. Now that you can see for these points, that green point, I can't select show object. The reason why I can't select object, by the way, is because it's linked to this checkbox, which means I go here, you see A, that's the name of the checkbox. It's only when it's checked does it show up. So it's checked right now, that's why it shows up. So we're going to get into that a little more probably in a few videos, but you want to give a chance to, you want to make it so that the structure that you want to show stays where it is. Okay, so that's that example. Now this one just really shows that, when you want to make a point somewhere, sometimes you can even put it on the X and Y axis. So if I make have just a segment made by, or a line made by these two, I don't really like the fixture grid when you're moving a point around like this, but so if I just want to know what the y-intercept is, all I do is do intersect of this line and this, and then that wherever it is, wherever it crosses the y-axis shows up with the the y coordinate, which tells you what the y-intercept is, which is nice. So if you go all the way around, it's not going to show up until you come around right there, and now it shows up right there. So that's another way you can sort of limit, where this point goes. The last thing that I wanted to show for this video was this right here. And so if you wanted to, let's say, manipulate the grid, you could also limit how, or how where you can move the point. So I'm manipulating the y-axis with this, and I can manipulate the x-axis with this. And all I did for this was I just made a number. I called it A, and I made it like, I think 0 to 100, and B, I made it 0 to 100. I did this right on here with a slider. So I did that, and then I went into object properties, and you can try this. I went to this right here, and I just said -6 minus 6a. So this a was in charge of the x-min right there, and then it was also in charge of, the a was also in charge of the x max over on this side, whereas the b was in charge of the y min over here, and then the y max over there. So it's sort of set the parameters of the graphics view, and with that, so now whenever I move this, I move it, it always stays like it jumps from. It doesn't go. It's not like 1 1. It's not like it goes 1 1 1 2 or anything like that. It stays on the grid lines, and it jumps a lot more than it has. So it's one way to mess around with the graphics view. I'll show you one more thing on this, and that is that this. If I watch what happens when I change this, it resets to 0 0. Likewise, if I move it again over here, I'm just going to move this over here. I reset it again. The reason why I did that was because if I were to reset this, let's say very big, then it might get taken, one side or the other, or it actually would go there. But if I went from here, like for a second, if I went like let's say there, and then I went really small, it would sort of go up like that, something like that. I mean, I have to move both. So what I did for that was I went in here and I said, for A, set value A would be at 0 0. So, and that's on, it's called on update. So that means whenever the lever A is manipulated, on update, that's what it means. Whenever A is manipulated, on update, we're going to set the value of A, that's that point, at 0 0. So that's what that looks like. Likewise, I did it for B. When B is manipulated or updated, A is going to go to 0 0. So that's why that resets. I'll show you again. I move it just once and it goes back there, and then I'm going to do it like this, and that moves back there as well. So that's just a feature that you can play around with and get comfortable with. It will come up for in the future with making games and stuff. So